All right, let's get right into it. Today, we're prying open Python's data toolbox. We're going to look at the absolute must-have, essential tools that every single data scientist needs to master. And it all starts with a really simple question. So think about it. You and I, we know you can't add the word apples to the number 3. It just doesn't make sense. But why does a computer completely freak out? Why can't it even handle that idea? Well, the answer gets to the very heart of how programming works. And the secret is this fundamental concept called a data type. This is how Python, or any language really, makes sense of the world. A data type is basically a label. It tells the computer, hey, this thing, apples, that's text. And this other thing, 3, that's a number. You can't mix them like that. They play by totally different rules.
You know, the best way to wrap your head around this is to picture a programmer's toolbox. Every single data type is a different tool inside that box, and each one has a very specific job. You wouldn't use a screwdriver to hammer in a nail, right? Well, in the exact same way, Python won't let you try to do math with a piece of text.
Okay, so let's start with the most basic tools in our box. I'm talking the ones you're going to be reaching for all the time. These are your hammer and your screwdriver, numbers and the simple logic that makes your programs, well, smart.
First up, the integer. This is your workhorse. It's your go-to tool for counting anything. Any whole number. Doesn't matter if it's positive or negative, as long as it has no decimals. Like the number 2000 from the source material. It's simple, it's efficient, and it's perfect for when you're just dealing with whole units.
But what happens when you need a little more precision? You know, when close enough isn't good enough. For that, you grab the float. A float is just a number that has a decimal point. So if you're working with money, scientific measurements, or really anything that isn't a nice, neat whole number, the float is the right tool for the job. Now, for a tool that looks super simple but is incredibly powerful, the Boolean. It can only ever be one of two things, true or false. That's it. But don't let that fool you. This is the bedrock of all decision-making in your code. Is the user logged in? True. Has the payment been processed? False. It is your ultimate on-off switch. All right, so we've got our basic tools for handling one piece of data at a time. But what happens when we have lots of them, right? We need something to hold and organize everything. So let's look at the containers in our toolbox. The first and probably most common container is the string. Anytime you're dealing with text, I'm talking names, sentences, paragraphs, anything with words, you're using a string. It's just a sequence of characters wrapped up in quotes like the classic "Hello World." This is your tool for anything involving language. Next, we have the list, and this is one of the most flexible containers you will ever use. It holds a collection of items in a specific order, and this is the super important part, it's changeable. You can add stuff, remove stuff, or just shuffle the order around after the list has already been made. It's kind of like a multi-compartment tray where you can swap things in and out whenever you need to. And that brings us to its very close cousin, the tuple. A tuple is also an ordered collection of items, but with one massive difference. It's unchangeable. Once you create a tuple, its contents are locked in forever. Think of it like a sealed, tamper-proof pack of items. It's a guarantee that the data inside hasn't been messed with. So let's put them side by side, because this is it. The entire difference boils down to one word. A list is mutable. You can mutate it or change it. A tuple is immutable. It's permanent. It cannot be changed. If you only remember one thing from this section, make it this distinction. Okay, we've covered the basics and the everyday containers. Now let's get into the fun stuff. It's time to break out the power tools. These are the specialized organizers that solve very specific but very common problems in data science. First up is the set. Now, a set is a collection with a superpower. It only stores unique items. That's its whole deal. If you try to add a duplicate, it just ignores it. So what's the point? Well, if you have a massive list of user IDs and you need to know exactly how many unique users there are, a set gives you that answer instantly. No duplicates. And finally, we get to my personal favorite tool, the dictionary. This isn't just a simple list of things, it's a collection of key value pairs. And this is what makes it so brilliant. It's like a digital file cabinet. You have a key, which is like the label on the file tab, and a value, which is all the information inside that file. This whole structure is built for one thing: speed. So how does it work? It's really just a simple 3-step process. First, you create a unique key, say a person's username. Second, you store a value with that key, like all their profile info. And third, anytime you need that information, you just use the key, and bam, you get the value back instantly. No more searching through long lists one by one.
So we've filled up our toolbox. We've got our numbers, we've got our logic, and we've got a whole bunch of containers to organize our information. But why does any of this really matter? What's the big deal? Well, let's see how this all comes together.
Think of this as your quick reference guide, your when to use what cheat sheet. If you need a flexible, ordered collection you know you're going to change, grab a list. Need to protect your data and make sure it never changes? Use a tuple. Need to find only the unique items in a huge collection? A set is your tool. And for lightning-fast lookups, it is the dictionary every single time.
And here's why this matters so much. For anyone who's serious about data science, these tools aren't just nice to have. They are everything. You will use these fundamental data types every single day to clean up messy data, to structure it for analysis, to build powerful models, and ultimately to tell a compelling story with your information. So, your toolbox is now stocked with all the essentials. The fundamental building blocks are right there in your hands. You've got the hammer, the screwdriver, the power drill, the organizers. Everything's ready to go. The only question left is, what are you going to build first?